to turn this over to Joe and to Carbon Free Energy to discuss their turbine design. And go ahead, Joe.
Thank you, Eugene, for the invite. Boy, I seem like I know a lot more about data security now after listening to Firebolt a couple of times, but that's great.
Right, you had to sit through this twice.
Yeah, we're going to talk to you today about our innovative solution to making some energy. So what we're looking at is increased grid resilience and decreased cost. So the problem and what we're seeing now, obviously, is market and supply volatility. That's one thing. And also, of course, cost. And so we originally did not exactly think about this product for the military. I mean, not our original potential customers, but as we started to talk to people and then see what the possibilities were, then the military applications became obvious. And so I'm sure a lot of you are aware that the Pentagon's saying the estimated cost of liquid fuel in the field is about $400 a gallon. And so our solution looked at a lot of the problems associated with wind, and our technology is based on physics. And I used to be a race car driver. I did Formula 3 in Italy and then worked for the Aero's Formula 1 team for a number of years. And I took my basic understanding of airflow, because in my day it was all ground effects cars. And so the basic premise is that air accelerates over a curved surface. And there's a bunch of ways that we make a lot more power, and I can get into those when anyone has a question or later on in the presentation. So our technology, like you may have noticed from the first slide, it's modular and it's also scalable. So we do not picture a giant utility scale wind turbine using this technology, because it would just be way too cumbersome. So the other thing that we really wanted to think about was a US-based supply chain. And so as we're looking at all the different things, the elements that go into it, we wanted to keep it US-based for a number of reasons, and that was even prior to the tariffs and all the hassles with moving goods around the world right now, which are plentiful. So a number of applications, and we have all kinds of applications. And so one of them is putting them on a boat. And so on the earlier slide, I had this idea, but Porsche Engineering did all the ideation. They did all the testing. They came up with the final product. I approached them, and it's rare that they would work with a startup, that's for sure, especially one with not humongous pockets. But they were intrigued by this concept, and they actually told me they found it an innovative idea. And so that's why they pursued it. And so the detail there right underneath the C, that image could be a number of turbines right on the top of the ship. And their exact comment from this was, with a couple of turbine modules on the top of the ship, you'd make more power than if you covered the entire thing with solar panels. But that is just one application. Another one, cell phone towers, and I'm going to get to sea, air, and land here in a sec, but there's all different types of applications. Cell phone towers, you could integrate them into the actual building of structures. And then I live out in the country in Iowa, and it's windy here. And so there's a lot of farms around. And so one of the obvious applications is in a rural setting to power farms. And we have a number of interests from large ag producers because the economics change dramatically when your electricity costs are reduced. Applications then for generating power after a natural disaster. And so there's a FEMA slide there. That's one of the things that we thought of right away. And then also the whole idea of delivering power essentially in a container. And so when we first started this, we were thinking aluminum skins and that kind of stuff. And then as we proceeded farther, it became clear that we could use ballistic fabrics if we wanted to. So we can make it resistant to shrapnel or small arms fire. We've got a retired now Navy SEAL on our management team. He was active duty when we first started communicating. I saw something in the chat, but I didn't get a chance to see it exactly. He was talking about how it's easy to disable a solar panel with one round or that. And he was both in theater in Iraq and Afghanistan. The solar panels were very likely to be stolen as well. The connectivity, of course, is one thing. And so we originally thought of these as almost like remote hotspots. And so you could make the power, you could have connection either on a cellular network or a SATCOM network. And then also, as we started to dive deeper into the military end of things, it could also be eyes and ears in remote areas. And that is one application. Another one are drones. And so Northrop Grumman really liked our idea, and they thought of an application that we had not really thought of. And this was on the leading edge of an airplane wing or also on drones, because the housing can absorb the sound. And it also makes the aerodynamics a lot more efficient. And so the drone manufacturers we were talking to, and I must say it was early days, but what got them so excited was they were thinking, oh my gosh, this might make the drone more efficient, and they might be able to get 15% more range out of it. And then depending on what the application was, the sound mitigation could be of interest. Oh, yes. And this is what I talked about on the leading edge of aircraft wings, or even submerged in running water, because air and water have similar capabilities. And so it no doubt makes whatever turbine more efficient because it decreases drag behind the housing. It decreases the drag behind the blades, but it also creates a low pressure area behind the turbine. And so the ambient airspeed of the airspeed hitting the blades is actually faster than what the wind is blowing. So you get decreased drag and you get increased velocity hitting the blades. And these were our three customer segments that we're looking at: military, tribal, and agricultural. And progress that we've made. We have assigned CRADA with the Naval Postgraduate School. We have a signed letter of interest from the Oglala Sioux tribe, and the Oglala Sioux are in South Dakota, and it's some of the windiest spots in the entire country. They're certainly interested in tribal sovereignty. The Naval Postgraduate School and the military are interested in other things, but it's got to have dual use. Or if it has dual use, the interest goes up dramatically. They certainly want a civilian product to come out of this. Some of the benefits: it's got a lowered acoustic and visual signature. The blades can be painted. The housing can be camo. It can be anything. And the other thing is the significantly increased power outputs. And so we're looking at 2 to 3 times for a given rotor size. But we also wanted to address some of the problems of current wind turbines, that they kill birds and bats, that people don't want to see shadow flicker, that they don't want to see something. They want it to blend more into the landscape or the environment. And as I said before, the technology is scalable. So we just have something up there with about a 3-foot blade, but it can scale up or down. Also, the simplified field installation. So we have gone through so many virtual generations of how we're going to make it, what we're going to make it out of. And where we're at now is, I think, absolute state-of-the-art solution for both manufacturing and installation, that it's assembled on site. And it's going to be 3D printed and then locked together. And what we're envisioning is when you opened an Apple computer and there would be some graphics that were very clear on what had to be screwed in where and how it was going to work, and no specialized tools required either. Because, again, this is not utility scale turbine, obviously, but utility scale turbines just require specialized equipment and experts in the installation. And so there's a couple of pictures there. I think that's the ISU 90 container. And so we envisioned pushing these out of airplanes or helicopters or brought in on a truck anywhere they need to go. Everything is contained in the container, and then you put it together in the field.
Hey, Joe, this is Eugene. I'm gonna slow you down here.
All right. I'm going too fast, huh?
so just a couple of questions. So now you talked about utility scale.
Yeah.
Can this be used? I mean, can this be scaled up for utility scale applications?
I conceivably, yes, but the amount of material that would be needed to house that utility scale turbine would be larger than we had certainly considered at the outset. And so, yes, it could be. There's nothing to say that it wouldn't be, but I don't think that's the best application of it, because getting a structure that large, I told you I'm in Iowa and we have tornadoes. I would not want to see one of those things close to a tornado. So,
all right. And then, so what about microgrid?
oh, yes, absolutely. That's where we're at, microgrid. So we want our solution to be a part of a microgrid because, again, in all the discussions with the Army and the Navy and the Air Force, it's not either or, it's and so one of the Army garrisons we were talking to in California, hundreds of miles remote, and so depending on the grid to deliver power to Fort Hunter Liggett, and that's PG&E, Pacific Gas and Electric territory, and they've had all kinds of problems with wildfires in California. They want as many different redundant sources of energy possible. And in the winter, the sun isn't as high in the sky and it doesn't have as many hours of sunlight. And so there's a natural drop off in the winter. Well, here where it gets cold, there's a lot more power in a cold wind than there is in a warm wind. When I say a lot more, and not dramatically, but considerably more, because the density of the air matters as it hits the blades. And so microgrids really our target market, really, or our target application to not have just one type of energy. And we really see it as a supplemental form of energy that we could deliver.
Okay, so then now if we take it a little bit further from microgrid, and let's look at Puerto Rico.
Yeah.
And Jamaica and the
You're
devastation.
Absolutely.
Now you talked about being afraid of tornadoes. What about hurricanes?
Well, any type of we've got ideas about how we can lower the housing or to shrink the entire thing, because you want to limit your cross section as much as possible in high winds. I mean, that's pure physics as well. So, if a Category 4 hurricane hits, I don't know. I'm not going to try and claim, oh my gosh, our turbine's going to be still standing, but we could certainly parachute them in afterwards and get the grid going again quickly, because the grid's going to take down, a hurricane's going to take down a traditional grid as well. I've got ideas for how we could minimize the hazards of an extreme wind event, but to be quite honest, that really hasn't been the focus to try and figure out that solution. We've got some ideas, and these things are very lightweight too, and so they could be deconstructed if you knew that you were going to get hit in 2 days or 3 days. So there is that possibility for sure. But as far as standing up to a Cat 4 or Cat 5 hurricane, I can't make any claims on that right yet.
Okay.
Any other questions?
Not for me, no.
Okay. From the chat, no, I don't see anything.
Nope, nothing in the chat. I prompted you.
All right, let me close this up then. The chat I made. Okay, so our ask, $350K to finish the CRADA with the Navy, with NPS, the Naval Postgraduate School. That estimated time to completion, 6 to 8 weeks. And then we had been in discussions, or are in discussions, with other elements of the Army, and they were talking about bypassing some of the prototyping and just trying to go directly to deployment. And that would be a TRL-9, and that would be about $2.4 million to have that ready, deployed operationally, full scale, ready to go, making energy at whatever scale was optimal for the application. And there are a number of elements that can be used off the shelf to determine how much power each module is going to make. And so the easiest thing is taking something off the shelf, and we can take modified car or truck alternators and make them into electricity generators. And another big advantage of our technology, the delta between our an unshrouded blade or our shrouded blades gets higher, more dramatic the higher the wind speed. Well, when we first started talking to large turbine manufacturers, there's no way they can adequately cool those giant generators in the nacelle of a utility scale turbine. So they have to decrease the amount of energy that they can accept. They can change the pitch of the blades, and they can do a number of things. With ours, I think there's a real possibility, well, I know there are real solutions to help cool anything that's going to heat up the generator. And so I think we can make a lot more power when it's windy. And so where a lot of the traditional turbines have had to scale it back once it hits a certain speed, I think we can take advantage of that. And when I showed the containers before, we'd like to have battery storage in there too. Because if you're not just burning it right then or putting it into the grid, you have to be able to store it. And so the battery backup was a piece of it too. Okay.
So then I got a question. So
yeah.
So go back to your application pictures. So I'm thinking about things like directed energy.
Oh yes, right. Uh-huh.
And and you mentioned FEMA, and I hadn't thought about FEMA before, but there you go, being able to containerize these and move them around.
Yes,
DLA could have an interest in this as well. Expeditionary forces within the military could have interest.
Yes, and I think that.
Go ahead.
Oh, go ahead, please, Eugene. Well, I think that's why this is so valuable. This whole everything that you've set up, because there's ideas that we haven't exactly considered, or angles that we haven't considered. So, any suggestions we'd love to hear.
Yeah, go ahead, Mark.
Just one thing, Joe. Have you had any contact with FDIC or the Fire Chiefs Association in the States? No.
FDIC, you said?
Yeah,
Mark.
Yeah,
Federal
FDIC.
Deposit Insurance.
No. So you wish. No. It's the Fire Department's International Conference.
Okay.
So there is a huge program that goes on every year. It fundamentally brings together all of the emergency services in reality, because in the States you're structured very differently to the way that we do it over here. So you have that, but also there is a event on every 5 years in Europe called Intershoots, and there is an event in Dubai called Intersec. Now, these three events, and for my sins, I ran a fire and security magazine for 7 years. I traveled the world talking. So I've seen lots of these cool things over the years. I would say that there are companies like NAFCO in the Middle East that have a lot of government contracts, that they're doing a huge amount. And this type of product would, I think, be quite interesting to them, especially with what's going on. If you can look at the fact that this can also potentially power missile launchers, not just energy.
Right. Yeah.
Right. You'll have some very interesting user cases from a defensive posture, not just an energy consumption, because again, it's a premium with space. But I would also say in areas like California, where you get the wildfires and things like that, there may be, getting generators, especially if you talk to anyone that was on the ground during that incident, that they were at a premium. So again, a little bit like what Starlink does. Right. Can you mobilize yourself as an emergency alternative? Because I think that there's the fire chiefs in the States have a lot more control than anyone realizes. They control their own pockets. They make their own decisions in reality. And there's some really good people within that house. So yeah, just talking out loud while you got FEMA, I think, you're very lucky to have everything integrated in that respect, because it tends to be one voice that communicates it across. So yeah, just thinking out loud for you guys.
Sure. No, brilliant suggestions. And BC's got his hand up.
Brian.
Yes.
Go ahead, Brian.
Thank you for that, Mark.
I lost you, Brian. I know he put his email. There we go.
Okay. I put my email in the chat, and I'd like to connect with you. I'm an R&D engineer for a volcanic basalt factory, and we're gearing up to specifically make Arctic and tropical rated composite shipping containers that last 100 years. And I can also supply you with power poles, concrete, and other types of basalt composites and aerogels that could get you into California. A lot of our stuff is already used with California Transit, and our stuff's NASA and military rated as well. Just Fantastic. Not a lot of people have heard of basalt.
Great. And I've got Todd Bressler. He's part of Carbon Free Energy too. He's on the call. So I'm taking some notes too, but I'm sure Todd is taking those. So it's Brian, was it?
Yeah, Brian Crowley.
Yeah, Brian. We'll connect after for sure.
Perfect. I appreciate that. And feel free to connect through Eugene as well. He knows me well.
Okay, super.
So now, Joe, how did I can't remember how we connected. Did we connect at one of the disaster expos?
I think you connected with Todd. Todd, how did you and Eugene?
I don't know if we were introduced or.
That's a great question.
Oh, was it Ruth Ann? Was it Ruth Ann Darling?
Oh, maybe.
It might have been that, and I got in. I think I received some sort of group communication.
Oh, that's what it was. Yeah.
Yeah.
So from Ruth Ann, because I was working with Ruth Ann on the space-based solar power stuff and terrestrial wireless power. In the past. Okay, but there is a whole disaster community that I can introduce you to.
No, I think that'd be great, because how we really got on with the tribal nations was Todd was friends with the Native American and up in Northern California, and she said that 1 million acres were burned from whichever wildfire, and it devastated their entire reservation. And so that's how that started. Okay.
And then now, how about the Canadian DRDC? I'm not
real familiar with that. No.
Okay. So that's it's their defense R&D, and it's but I did a lot of work with them when I was at the Naval Research Laboratory. Mm-hmm. And this could help in the remote northern regions where they're having to burn diesel.
Exactly.
So
yes, and cold weather locales, the numbers make even more sense quicker because where it's cold and it's windy, that is like the Mojave Desert if you had a solar panel. So
the challenges you're going to have, though, are going to be vibrations transferring heat into the ground and melting the permafrost. That is going to be the big challenge for those applications.
Okay. Yes. Yeah, it depends. I mean, with the containers that Brian was talking about, would those isolate temperatures from the outside better than a steel structure, or?
Oh, they probably, yeah. And you could probably, the way you show these here with them on top of the containers, now, and then you can put dampeners on the bottom of the containers that restrict the vibrations, but yeah, that's the only challenge is going to be because in they can't really do solar in the wintertime. There's no solar. There's tons of wind, of wind.
Yes,
but no sun.
Right. Yeah, no, that's a fantastic angle.
Yeah, so there again, I can the cold region was it Creel, CREEL. But basically, it's like the civil engineers for the cold region.
Mm-hmm. Okay. Right.
They're up in Alaska.
Fantastic. No, it sounds good. So
but yeah, I can make some of those introductions.
That would be fantastic, Eugene. Wonderful. Okay. Any other comments? Should I proceed, or anyone more interested in the technology, or let me see where we got this. I mean, it certainly has changed dramatically from where we started. I mean, you have to pivot, of course. That's any entrepreneurial endeavor. But we came up with that. Here are Todd and I. Todd's got our contact info in the chat. And then I'm here for questions. Anybody?
So when you're talking about cooling challenges,
yes,
and wind speeds,
yes,
can you gear these up and down, or are they normally geared up and down to adjust for that?
Yes, you can do whatever. I mean, simplicity is always better. Obviously, a gear's not a huge thing, so yes, that can be geared down. But the idea of air cooling, Porsche started off with air-cooled engines, and we were discussing this. We were talking about, well, if it's really windy, we can have some kind of duct, and then it just brings air right onto the generator. But there's ways. There's so much technology now with electric vehicles and keeping motors cool and everything else that it's a relatively easy solution. Now, it might add some weight to cool it with oil, but we're only talking, these generators are small. I mean, they're not very big. And so the Porsche guys laughed when I asked them about, could you cool them or could you handle the horsepower or whatever? And those are very manageable engineering challenges to overcome. It really is reliant on the application. You know, what is the exact application needed? We talk to a maritime environment, or we talk to a cold weather environment. So we talked about a hot weather environment, a saltwater environment. I mean, all of those things. So we even had considered at one point making a configurator like you were making a car. What do you want to do with it? Because there's all kinds of things that can be done at multiple levels to make sure that the application, if it has a specific requirement, we can meet it.
And then now the motor side of this. So
yes.
So there's a company that I and Brian is aware of them as well, but they have a motor with near zero eddy current, which makes it very efficient and very cool running.
Very
is that
pricey?
No, not at all. Not at all. So it's and I sent your information to the main investor in that company, who's part of my network.
Fantastic.
But I wasn't quite sure if that technology would be able to assist you and in your operations of your turbine.
That's certainly something that we would look at very closely. And the reason that it just made sense because we're of course thinking about cost, and originally we were going to have a specific generator made for our applications of a 10 kilowatt turbine, and it was so pricey, and it was going to be made on a very low run quantity. And if we can modify, and this was the Porsche guys' suggestions, we can modify a car or truck alternator, and they're making hundreds of thousands of them, if not, maybe not millions, the exact same size, but hundreds of thousands. And so the economies of scale are just, I mean, what was the cost? Not even 10, I mean, it was like 1/20th the cost of the generator that we were going to have made, or one that would be modified to fit what we needed to do. So that was an easy one.
Yeah. Because and then looking at the utility scale, I really think that's something that you may want to look at sooner rather than later. And and if there are investors here on the call, there might be an interest, because I was reading about some of the earlier wind farms that were installed off the coast of Europe. Those propellers are just disintegrating now. And so they're going to have to replace them. And I could see your thing either replacing that entire pole and possibly being even that tall and having that many turbines, or even getting mounted on the top as a larger series of turbines.
Well,
or even if you did like, I don't know if you can do like a 3x3 grid.
Sure. We looked at all of that. A massive wind wall, we called it.
Exactly. Yeah.
Yeah. I mean, and it's possible though, since we're going to make a lot more power than an unshrouded blade, our turbine could conceivably be half the size of a utility scale turbine, but still make as much power. And so then everything gets smaller, and then you use less material. And so it's, yeah, we're willing to listen. That's for sure. Todd, you had a question?
Well, I mean, Eugene, you're exactly right. I mean, that was the conversation that I had with the governor's office in California. I mean, one of the first things they said to me is, can you do this utility, and can you do offshore? And it wasn't, like, it was, when can you deliver? I mean, that was the type of addressing I was getting. They're ready to move. These people are ready to move. We just need to deliver.
Yeah, and there's Brian. I was just going to bring Brian up, and the basalt is so much lighter than most composites and stronger. So you could make your blades out of the basalt as well as the housings, and lower the weight considerably, and improve your ballistic capability.
Sure. Okay, let's see. Well, I mean, I'll show you some of the things, and if nobody's interested in hearing about the technology, I don't certainly have to cover this, but this was a good picture of what happens behind the blades. And so there's a lot of turbulence behind the blades, and that's a lot of times why the Betz limit 0.59, saying that you need 40% of the energy to be going through the blades. Otherwise, they're going to stall if you try and capture all of it. Well, when the resistance is behind the blades, a considerable amount behind the blades, then you can get more flowing through it. And so when we first started talking to the local utilities, there's no way you're going to get past the Betz limit because, A, B, C, D, and E. Well, no, we have gotten around that because...
Can you explain that for the lay people, what the Betz limit is? Not everybody's going to know.
Yes. Thank you for asking for that clarification. The Betz limit is the theoretical limit of how much power a wind turbine can make. And so it's generally been accepted for the last 50 years now that you can't go higher than 0.59. Converting 59% of the kinetic energy in the wind to electrical energy. And so then my next slide here, that diagram on the right, by forcing the air around the housing and through the housing, because there's also some magic going inside the housing, it creates a low pressure area behind the turbine, and it forces the air through. And so sometimes if you've had a couple of doors open at your house and you feel the wind and the wind wants to shut one of those doors, that's the same type of effect. You can literally feel the air accelerating through the house or through the garage, and you can feel it. And so it was that idea of, okay, let's create a low pressure area behind the turbine. And then we reduce the drag and we increase the speed of the air that is actually hitting the blades. So that's our magic. And then here, it's the Porsche's work that they did with a housing, without a housing, with things within the housing. Let's see what else I have. Oh, yeah, and then some of the results. So where we're saying 2 to 3 times, these theoretical power over velocity that Porsche came up with, I mean, it's 5 times the power. And so I don't feel exactly, but I'm not going to claim that. In their testing, they did see 2+ times the power that they tested and measured. But I think, like I said before, I think our real advantage might be storing that energy that we can produce when it's windy out. So let's see. I don't really have any other technical stuff. I mean, just some people on the team, military terms. We probably don't need that. So, the support. We've talked to so many people in California because they understand this quickly because of the wildfires, because of the mentality of trying to save money too, because their energy costs are high. So
they have the Santa Ana winds too every year,
and they have exactly. And anyone who's ever driven out to Palm Springs from LA sees all the wind turbines out there. And so the other thing that we wanted to address was that it would not be an eyesore, and so we feel like it's more of a architectural element that you might see, and then the birds see it as a structure, and so they avoid the blades. And then for the bats, the compression waves are absorbed in the housing, so you don't get the bats sonar really thrown off because of the compression waves from the blades.
Since you're looking at smaller areas for your turbines, than having a 100 foot long blade, have you looked at putting grids in front of them, and what challenges that would introduce, and how that would impact your benefits?
No, you mean to prevent any birds from getting or something to the blade?
Would that be a challenge at all?
No, I don't think so, because the what we had talked about was putting owls, fake owls on top of the turbines, or coating the inside with a nano coating that would be super slick, that would prevent any birds from nesting in there or anything like that. So, boy, we have certainly examined a lot of things. We talked about putting a grid in front of the blades in case there were some high wind speeds and we wanted to completely close off the inlet. And so then you'd essentially be looking at an airplane wing that was facing into the wind. So I think that could handle a lot of wind speed. Like I said before, I don't know if it could handle a Cat 5 hurricane, but who knows? And one way to find out is to put one on an island somewhere and see what happens.
And now, so this whole conversation has been around wind, and so let's take it beyond that. And would your turbines and this design be beneficial to hydro? Could you capture energy from a river, from a water, without creating a dam and a waterfall? Could you capture energy from ocean currents? Those kind of things.
That's a great.
And would you have the same efficiencies, or would you have an improved efficiency with your design over what exists? Does that?
Yes, I think you would have a very large increase over the efficiency. And that's where a grid might make a little more sense, to make sure that fish weren't, if it was in a stream or a river or something, that they weren't doing damage to the blades or any of the internal components. But there's no real internal components. It would just be the blades. Yes, I would love to see this in a hydro application, because, as I mentioned at the very beginning, air and water have very similar properties. And so I would love to see how this might work in a hydro scenario. And we've got actually a really good hydraulics lab at the University of Iowa. I'm gonna go over there and ask them what they think about it. And they've got all testing capabilities there. I'm sure we could figure some things out.
Yeah, I'm going to be in Salt Lake City. I don't know how far that is from you, but if in June, if you're available. But so then the next question I have, I'll get to you next, Jay. Sorry. Well, no, let's go ahead, Jay. You got to go ahead and ask your question.
Hey, hi, thank you so much. I just wanted to jump in and on this, I'm a water nerd and we can go into it deeply, but that's part of where I see an intersection in a lot of places, but I would say especially in defense spaces right now. And I think I have input, but I just want to say there is an intersection here, and this is the place to build it out. Water is finally being recognized as a national security element, both in vulnerability but in strength. And you're on the strength side, and that needs to be built out both in concept and in practice. But it's just to give a taste of it, many of the AI data center needs are rooted in water availability. And part of what you're talking about, even though it's, is separated by steps and points and technical issues, it's in the same conversation. So just so you know, go that direction. And if I can help, I certainly will.
Yeah,
okay, thank you very much.
If you could put your email in the chat, and it might be a good conversation, because the next place that I was going to go with this is, if you're creating that low pressure behind the turbine and behind this system, you would be able to address the problems with cavitation of propulsion underwater,
right?
And you could lower the cavitation. So that is now getting into what I like to call the art of the possible. So now we've gone from what you designed this for to what the art of the possible for this design is. And I think Jay hit it, and having worked at the Naval Research Laboratory and at NAVC at Carter Rock, where we design ships and working on signatures for ships and subs,
right?
I can see real applications here for the whole system underwater.
Yeah, I think so too. At the very outset, we were thinking of ships, but above the water. line, not below it. And so I love the ideas. That it just makes total sense.
Yeah. Even wing and ground aircraft. This would probably be, where they gain lift from being close to the water.
Right.
Did I have that right? I think it's wing and ground. I deal with so many different technologies, I get lost. But
I know
yeah,
what you're talking about. Yeah.
Last week was invasive snakes in Guam. So. But yeah, no, thanks, Jay. That was some good input, and and that's the thing, and then you can look at hypersonics, and if you're addressing aerodynamics problems and then addressing hydro problems at hypersonic speeds, air takes on the properties of water. And so now your design may have applications at those speeds as well. And and we can take this and put this in front of Air Force Research Lab if there are people here that have that. Otherwise, I can make those connections as well.
Wonderful. Yes, and James Edmonds in their ground effect. Yeah, that's it's what it is. Yep.
Okay, so back to the community. Anybody? Any questions?
Comments, ideas? We'd love to hear them. But if you think of something in the future and you know how to get Eugene, or you copied Todd or my contact info, please reach out.
Yeah, and I'll send you all this information, and you'll be able to follow up with everybody, and you'll have all the transcripts and everything that's in the chat, so you'll know what to reference.
Oh, fantastic. We've got a question from DB.
No, I was just going to basically say this is exactly what I envisaged this forum being about. And
yes.
You've got you've got so much work to do after this last 10-minute discussion.
Yeah.
Your business plan's now written for the next 5 years.
I never looked at it that way, but yeah.
No, it's wonderful.
And I have to say, I had someone send me an email. They work with the federal government for setting up national, they basically look at the future forecast for the national labs, and they actually sit on our forum. They attend our forum and watch our videos, because we are hitting the next state-of-the-art stuff, and they are using that to plan what sort of capabilities they want to bring into future labs. So I was quite excited about that. I don't know somebody's got feedback. I don't know if that was you, Mark. Okay. Yeah, so I was quite excited about that, to know that people are actually using this, because we did the space rocket or the nuclear powered rocket, and they actually reached out and said that they wanted to be able to, they saw that as a future technology worth developing, and they wanted to be able to make sure the labs could support it. So.
Yeah. And can I just put in another point about the labs, since what we're dealing with is we're going to find the limits of AI and simply data. And where the labs come in is ground truthing and actual testing of the conditions that go ahead and provide the resources that have been described so well today. There's got to be a connection. It can't be all data. It has to be ground truth, and that's where the labs come in.
Right. Yeah, and we are part of the federal lab consortia. So there's like 135 different labs that are part of that within the U.S. federal government.
Fantastic.
All right. So thank you, Joe.